All right, this is Horner again. We're going to do 1998 B4 with a live audience. All right, here we go. This problem says draw a diagram of the circuit below using the following symbols to represent the components of your diagram. They tell you that all the light bulbs are identical, which means that they all have the same resistance. Assume the battery maintains a constant potential difference, so the voltage is the same, and the resistance of each light bulb stays the same. One thing that I'm going to do is I'm going to put 1 ohm on each one of them. That will help us later when we kind of think about what's going on in this circuit. They want you to draw a diagram of the circuit in the box using the symbols that you see here. So what we'll do is we'll go ahead and put our battery in. So here's our battery. And then we have a wire leading over to letter B. So this wire goes to letter B. So here's our letter B. And then letter B is attached to two things. Notice that it is attached to D and it is attached to C. So I'm going to move over and I'm going to do one here that's going to be attached to D. And then if you look at C, you'll notice that it kind of comes, you've got one wire going here, and then you've got a wire after it going, oops, you've got a wire after it coming down to this next one, like that. And this is letter C. And then let's kind of check where the wires go. So now we've got a wire going from D all the way down to C. And then finally we have one more wire that goes from this side of C over to A and then back to the battery. All right, so now what we need to do is look. Let's look at this and kind of see what happens here. Notice that I think what we've done is we have D going, oops, we don't have D connected to the correct side of B. So let's change that. We're going to move this end of the wire to the front side of this. Okay. Now that we've done that, what do you notice about B and C? Well, you should see that B and C are in series. D is in parallel with these, and A is by itself, so it's also in series. I'm going to redraw my diagram just to make it a little bit easier to see kind of what's going on. So we've got a wire going over. We have a line going down to B and another one going down to C. Then we have D right here. And then they go over to A, which then goes back to the battery. This one might be a little bit easier to see what's going on, but if you drew this one, they'd have to give you full credit. It's not a very pretty problem, but it works out if you do it this way. So either of these pictures would be fine. I think we really want this picture. Makes it a little easier to see what's going on. Okay, so let's do the next thing. Let's just put a voltage in front of the battery. So we're going to call it 15 volts. And if we have voltage, and we know the voltage in each one of these might be different, we can go through and actually kind of guess on some voltages. In some other problems that we've done, anytime, and I'm going to use this diagram, I think it'll be better. So this is 15 volts. Whenever you do these, usually a great deal of the voltage goes to the first thing in series. So this, we're going to put 10 volts. In order to find out what voltage is going through each one of these branches, remember you just take 15 minus 10, and that would leave 5. So D definitely gets 5 volts, but then B and C, that needs to add up to 5. So we're just going to call these 2.5 and 2.5. So now we have voltages, okay, for each one, and we know the current in each one is 1. They want us to list the bulbs in order of their brightness, from the brightest to the least bright. Let's think about our equations. So our equation is V squared over R. And since our resistances are the same, we just need to look at the voltages. If you look at the voltages, you'll notice that the biggest voltage is A. So the brightest is A. The next brightest one would be D, because it's the next highest voltage. And then the next highest one is a tie between B and C. So you could actually write B and C. Our problem is we now have to justify our answer. So to justify your answer, I would put for A, and then put an arrow, and put V squared over R, and then write a statement. That's equal to power, sorry, and then write a statement. A is the brightest because power is equal to V squared over R, and A has the most voltage. Your next brightest, so I would say D is next. It has 5 volts. Oops, you know what? This one was really has the most voltage. Yeah, it has 5 volts. And then B and C have same brightness because 2.5 volts. Now you would probably want to write a little bit more than what I have here on the actual AP1 test, but that is the reasoning why those bulbs are all different, except for B and C, which are the same. Let's go ahead and look at the back side. When you look at the back side, so I got to wait for this to go. When you look at the back side, it says bulb D is removed from the socket. So now we're going to take bulb D completely out. Let's go back to the drawing that we had. So we've got this coming over here, going down to B, which goes down to C, which then goes over to A, and then goes back up. So in the last problem we did, we had a very similar thing happening here. If I get rid of D, this is no longer there. So now I still have B, C, and A. And when I remove D, I get this circuit, and it says, what change in brightness would I have? So A, from what we remember before, A will get less voltage. So now this one gets less voltage. And so therefore, A is dimmer. And it's because all three of these will now have the same voltage. So if we said that this was 15, these would all be 5 now. 5, 5, and 5. And before, A was higher. A was 10. So A is dimmer because it has less voltage and less power. The last one says describe the change in brightness of B. And just like the last problem that we did, you'll notice that B before was only 2.5 volts. Now B is 5 volts. So you could say B goes from 2.5 to 5 volts, which also increases power. So it is brighter. And those are the word explanations that you need for these. And that is the end of this problem.